In this video, I will derive the difference between Cp and Cv. Cp is the heat capacity under constant pressure condition. Cv is the heat capacity under constant volume condition. The difference is T times delta P over delta T under constant volume condition times delta V over delta T under constant pressure condition. This equation holds for all matters. We start from H equals U plus PV, which is the definition of enthalpy. Therefore, dH equals du plus PdV plus VdP. Note that there are only two independent variables among PV and T. You can pick any two. Therefore, we can write H is a function of Tp and U is a function of Tv. And then we expand dH. dH is simply delta H over delta T times dt plus delta H over delta P times dP. How about volume? Does enthalpy depend on volume? Yes, it does depend on volume. However, the dependence is included in here implicitly because pressure and temperature does depend on volume as well. And now we expand du. du is delta U over delta T times dt plus delta U over delta V times dV. Over here, but does internal energy depend on pressure? Yes, of course. However, again, this dependence is included implicitly in these two terms. And finally, we have this PdV plus VdP term. So you have two terms on the left, four terms on the right. It sounds very complicated. And then we're making it more complicated by expanding this delta H over delta P and delta U over delta V. Delta U over delta V is called internal pressure, this term. Under constant temperature condition, delta U over delta V is called internal pressure. Using Maxwell relations, we can express this internal pressure to be T times delta P over delta T at constant volume minus P. Similarly, we can derive delta H over delta P at a constant temperature condition. It's V minus T times delta V over delta T under constant pressure condition. Again, this derivation entails one of the Maxwell relations. Anyway, now we have three terms on the left, five terms on the right. But fortunately, we have VTP and VTP cancel. This negative PdV plus PdV, they cancel. Therefore, we have only four terms. Now we just move this Cp and Cv to the same side. So we have Cp minus Cv here. And then we move this part to the right-hand side. Now, because volume is a function of pressure and temperature, therefore dV equals delta V over delta T under constant pressure condition times dt plus delta V over delta P under constant temperature condition times dP. And we plug in this expression of dV in here. So we're going to expand this dV to the sum of these two terms. Now it seems that we make the equation more complicated by having three terms on the right hand side, but you will see the first term and the third term will cancel. If you look at this part carefully, and this is part of the equation in the of the triple product rule. Let's look at the triple product. Delta P over delta T sub V times delta V over delta P sub T times delta T over delta V sub P equals -1 if P, V, T depend on each other. And therefore, we have this product, delta P over delta T times delta V over delta P. So it's just this part. This part is the -1 divided by delta T over delta V. So it's here. And then the reciprocal of delta T over delta V is delta V over delta T. As long as they have the same subscripts. Look at here. You have this sub P and you have sub P here. So it's just imagine it's an isobaric condition and volume is a function of temperature and temperature is a function of volume. And therefore dt times divided by dV is the reciprocal of dV divided by dt. Therefore, we have this equation. And then we plug in this expression in here to replace the product of these two first derivatives. And then we have this equation here. And again, if you notice this first term and the third term cancel, we simplified the difference between Cp and Cv. Cp minus Cv times dt equals this part times dt. And therefore, Cp minus Cv equals T times delta P over delta T sub V times delta V over delta T sub P.